So let's look at an example where we apply these properties of definite integrals. So here I want to suppose that f and g are integrable and that the definite integral from 1 to 9 of f of x dx equals -1. We have the definite integral from 7 to 9 of f of x dx equals 5. And last but not least, we have the definite integral from 7 to 9 of g of x dx being equal to 4. And we want to find the following three parts using those properties of definite integrals. So let's go ahead and take a look. Part A, find the value of the definite integral from 7 to 9 of 2 GW dW. So the first thing I'm noticing is this constant 2. Let's pull that out in front. So by the constant multiple rule, we have 2 times the definite integral from 7 to 9 of GW dW. And we look up at these three given conditions here, and we think, oh no, we don't see anything that looks like GW. But then we take a deep breath and we realize, wait, the definite integral doesn't depend on the variable, it depends on the function. So looking again at these three cases, we realize that this third case here looks an awful lot like, or looks exactly like, what we have in case or part A. So we can go ahead now and rewrite this in the equivalent form, 2 times the definite integral from 7 to 9 of gx dx. And so now we're ready to evaluate. So this is going to be equal to 2 times 4, which leaves us with that beautiful final answer of 8. And we're moving on to part B here. So in part B, we are asked to evaluate the definite integral from 1 to 7 of f of x dx. So when we look at this, we realize, we don't have anything exactly like this definite integral up here. But we can see that these first two definite integrals that are given have the same function, f of x. And if we look at the bounds on these, we realize that we could manipulate this by the additivity property. So looking at our definite integral, we can see we have an upper bound of 7. And looking at the three cases that were given to us, we see that the second definite integral has a lower bound of 7. So we can manipulate this using that additivity property and say, by the additivity property, that the definite integral from 1 to 7 f of x dx plus the definite integral from 7 to 9 f of x dx is going to leave us with a definite integral from 1 to 9 of f of x dx. Because we have, and this is because we have 7 is living within the closed interval from 1 to, the open interval from 1 to 9. So keep in mind, what are we solving for? We want to solve for the definite integral from 1 to 7. So using a little algebra, we can subtract the definite integral from 7 to 9 of f of x dx from both sides. And so this leaves us with the definite integral from 1 to 7 of f of x dx. And this is equal to the definite integral from 1 to 9 of f of x dx minus that definite integral from 7 to 9 of f of x dx. Good old algebra to our rescue again. And so now we're ready to evaluate. We know that the definite integral from 1 to 9 of f of x dx is equal to -1. And we know that this is going to be minus the definite integral from 7 to 9, which is equal to 5, for a beautiful final answer of -6. And last but not least, we have part C, where we are asked to evaluate the definite integral from 9 to 7 of the functions g of x minus 3 f of x. And the first thing we're noticing here is that our bounds are backwards. We have the larger value in the lower bound and the smaller value in the upper bound. So we need to flip those bounds. And we know that we can do this by the order of integration. So this is equal to the definite integral, and don't forget we have a minus out in front when we flip those bounds. So this is minus the definite integral from 7 to 9 of g of x minus 3 of f of x dx. So our bounds are in the correct order now. And the next thing that we're noticing is that we have the difference of two functions. So we can separate this to the difference of two definite integrals by that sum or difference property. Just be mindful of that negative. So we have minus the definite integral from 7 to 9 of g of x dx minus the definite integral from 7 to 9 of 3f of x dx. And so let's go ahead and distribute this negative through so we have a little bit less going on. So we're distributing the negative through to both definite integrals, which leaves us with minus the definite integral from 7 to 9 of g of x dx plus the definite integral from 7 to 9 of 3f of x dx. And we're almost there. The last thing we're noticing is this constant 3. So we can apply that constant multiple rule and pull this out to the front. So I now have minus the definite integral from 7 to 9 of g of x dx plus 3 times the definite integral from 7 to 9 of f of x dx. And so we're ready to start evaluating now. We can see that both of these definite integrals are direct evaluations. We have g of x here is equal to 4, and the definite integral of f of x with these bounds is equal to 5. So let's plug them in. So we have minus 4 plus 3 multiplied by 5. So this leaves us with negative 4 plus 15 for a beautiful final answer of 11.